let's take a look at our first few phrases and determine what is the algebraic equivalent to these expressions. So here we go. We're going to write each English phrase as an algebraic expression. Our first phrase, for more than a number. Now, when you see the word more, hopefully you think of the addition sign. A number, you're going to choose that number. That is an unknown. Most students like to use the variable x just because x is the most popular variable. So for more than a number, we'll start out with our x. And then for more than that would be to add 4. Let's look at our second phrase. Triple a value. Again, that value is an unknown. We want to triple that value, or in other words, we want to multiply that value by 3. Again, if we choose our favorite variable x and multiply that favorite variable x by the number 3, 3x would be the equivalent of the phrase triple a value. Let's look at our third expression. 8 less than a number. Now, let me caution you on this particular example. First of all, we see the word less or the phrase less than. When you see the word less or the phrase less than, what comes to your mind is hopefully the operation known as subtraction. Less than, subtract. Now, we want 8 less than a number. One thing that's important when translating any of these phrases that involve subtraction is that you have to remember the order in which you subtract makes a big difference. For instance, we know that 8 minus 3 is not the same as 3 minus 8. So if we get the order of our subtraction incorrect, then we'll have the incorrect solution. So keep that in mind and read the phrase carefully. So let's look and see which way should we write our expression. 8 less than a number. So would you agree with me that we take our number and take 8 away from our number? So our expression would be, here's our number, and here's 8 less than our number. If you were thinking of the other way around, or 8 minus x, that would have been written this way. It would have been a number, it would be a number less 8. So a number less 8 would have been the other way. But we have 8 less than our number, so we take our number and then we subtract our 8 there. I know it's a bit confusing. It's going to take a little practice, especially when it comes to the operation of subtraction. Now let's look at our fourth here. 1/4 of a height. Are you sick of the variable x yet? If you are, let's go ahead, and since we're looking for some height, let's choose the variable h this time. So in this case, 1/4 of, that's a big hint and a big clue. Whenever you see the word of, think of multiplication. So we're going to translate of into multiply. So 1/4 of, or times a height, and that height is unknown. We're going to use h to represent the height. Would simply look like this. 1/4 times our height h, and we'll just write it down in that fashion. So this is the same thing as 1/4 of a height. Now, let's look at our next example. It's a bit more complex than our previous 4. Let's read the expression. 8 more than triple a number. Now remember, we looked at the phrase triple a value or triple a number right up here in problem B here. So triple the value we know is 3x, or triple the number is 3x. Now in this one, besides just tripling the number, we must have 8 more than this. So 8 more, whenever you see the more, hopefully you're thinking addition. 8 more is simply add 8 to that tripled value. Let's try one last one at the bottom here. A number is increased by 8 and then it is tripled. Very similar to this one we finished. This one that we finished, remember, was 8 more than triple a number. This one says a number is increased by 8. That's the first step. So a number increased by 8 would simply be x plus 8. There's our number increased by 8. Now let's read on. And then it is tripled. So what that's telling us is the entire expression, x plus 8, is then tripled. So we're going to multiply the expression x plus 8 by 3. So what's the difference between these two last problems? In the first one, we have the number 8 more than, and notice it says triple a number. Triple the number, 3x, 8 more, plus 8. Versus this last one here, which looks very similar, says a number is increased by 8. That's our first step. There's our number increased by 8. And then it is tripled, so the entire quantity is then tripled. When translating these phrases into algebraic expressions, you must read everything very carefully, word for word. Now in these next phrases, they get a little bit more complicated, but we'll take it slowly, read it carefully, and find some expressions that represent what we're looking for. In this first statement, we're going to find a variable and an algebraic expression that represents the following. It says Marie works 17 hours per week less than Anne. So we need to find a variable and an algebraic expression that represents the number of hours that Marie works and the number of hours that Anne works. First of all, who works more? It says right away, Marie works 17 hours per week less. So the person who works more is Anne. So we'll let x, our variable, represent the number of hours that Anne works. Now, we need an expression that will represent the number of hours that Marie works. How does her number of hours compare to that of Anne? Well, right in the first statement here, it says Marie works 17 hours per week less than Anne. So we'll take Anne's number of hours, subtract that 17 since we're less than, and that will represent the number of hours that Marie works. Now, please get used to the fact of labeling your variables carefully at the beginning here. What this is leading up to is solving more complex problems. So the first step in solving our complex problems is going to be to name our variables, which we did here. Let's look at our second example. It says the first angle of a triangle is 16 degrees less than the second angle. The third angle is double the second angle. Describe each angle algebraically, or come up with again an algebraic expression and draw a diagram. So let's first of all draw a diagram of what's going on here. We've got a triangle and it has three angles referred to as the first, second, and third angles. So we'll call this one here the first angle. Here's our second angle, and off to the right here we'll call this our third angle. Now, what do we know about these three angles? How are they related? Well, notice first of all that each the first and the third angle is compared to the second angle. The first angle is 16 less than the second angle. The third angle is double the second angle. Knowing that both the first and third angles are going to be compared with the size of that second angle, it would probably be a wise choice then to let x represent the measure of that second angle. Once we do that, we're going to go back and read the first phrase. The first angle, which is down here, is 16 degrees less than the measure of the second angle. So that means we take the measure of our second angle, which is x, and subtract the 16. That'll give us the measure of our second angle. Or in other words, the phrase x minus 16 represents the measure of the first angle in our triangle. Finally, this third angle here, how does it compare to our second angle, which has measure x? Notice here it says the third angle is double the second angle. So if x is the measure of our second angle and our third angle is double that measure, that gives us 2x, an expression that will represent the measure of the third angle. So have we come up with an algebraic expression to represent the measure of all three angles? Yes, we have. The first angle, x minus 16 degrees. The second angle, x degrees. And the third angle, 2x degrees. On these problems that lend themselves to diagrams, it's always nice to draw it if possible because it helps you to picture exactly what's going on in the situation. If not, then just go back, read the words and the problems carefully, and you're on your way to solving your word problems.